Hello friends, today we are going to discuss our first workshop, which is CMOS inverter design. So CMOS inverter consists of one PMOS and one NMOS transistor, and so we would like to design a CMOS inverter with switching threshold VDD by 2. So this is switching threshold VDD by 2. What does this mean? So when V in crosses VDD by 2, V in crosses, say this is VDD by 2, V out should also cross VDD by 2. So this is V in, this is V out, and so at this switching point, IP greater than IN or IN greater than IP, depending upon whether output is going high or output is going low. So these are the inverter characteristics. So when input is 0, output is VDD, and when input is VDD, output is 0. So this is output, this is input. So when switching threshold is VDD by 2, so when input is VDD by 2, output should also equals to VDD by 2. Now let's see trick with which we design this inverter with switching threshold VDD by 2. We take a inverter, this is inverter, this is VDD, this is ground. We will connect input and output and say this is V mid voltage. So we will take W by L for NMOS minimum. M is here multiplier. For this, M is multiplier W by L minimum for PMOS. So here we will take M equals to 1, and for this we will keep on changing M1, 2, 3, 4, 5, 6 and so on, such that V mid equals to VDD by 2. So in this way we can find out multiplier M or size of PMOS for switching threshold VDD by 2. Okay, so in this we will simulate our circuit using LTSPICE. Let's see LTSPICE. So this is our LTSPICE tool, and here we are going to change our this multiplier for PMOS and find out switching threshold. Okay, before that I would like to show you model file. So this is the model file we are using. So for time being, just ignore what is MC. This is the threshold voltage for NMOS, and this is mobility for NMOS. Similarly, we can find out threshold voltage and mobility for PMOS. So this is minus 0.455 is threshold voltage for PMOS, and mobility is this. Okay, so here we will note down, we will find out, this is actually simulation way with which we found out. Let's find out theoretically switching threshold for, or you can say size of PMOS for switching threshold. So here when output is tripping, then IP equals to IN. So this is half mu P COX W by L. Say we are taking minimum size VGS minus VTP square equals to half mu N COX. So this is say P, W by L size N, and VGS minus VTN square. So here threshold is negative, so we will take mod. So this will this is COX, this will cut, this is cut, this is cut. So this will come like this: W by L P upon W by L N equals to nu N by nu P VGS minus VTN square VGS minus VTP square. Now VGS we want VDD by 2 because this voltage okay, this is my inverter, so this voltage I want VDD by 2, this is VDD, and say this is VDD is say 1.8, so VDD by 2 is 0.9 volt, and for I'm using 180 nanometer technology. Here VTN threshold for NMOS is approximately 0.3075 volt, and VTP equals to minus 0.4555 volt, and mobility for NMOS is 314 centimeter inverse per volt per second. Nu P equals to 114 centimeter inverse volt per second. We will put these value in this equation. So okay, so we will put these values of threshold voltage, these values in this equation, so let's see. So W by L P divided by W by L N equals to 114.9 minus 0.3075 square, 0.9 minus 0.455 square, and this will come like 5. So if I am taking W by L, so this is say M into W by L minimum divided by W by L minimum. This is for NMOS. So M multiplier for PMOS is 5. Okay, let's simulate our circuit. So here I am taking this as a 5. And size for length and width I am taking minimum 180 nanometer, and similarly for PMOS I am taking length and width minimum but multiplier 5 for PMOS, but for NMOS I am taking multiplier 1. So it means PMOS size is 5 times or PMOS width is 5 times of NMOS. Okay, so this is DC simulation. In this simulation I am taking same sizes. Now let's simulate. Okay, so first we plot this. So let's see what's value come. So this is 820 millivolt, close to VDD by 2. And okay, now we need to run this DC simulation. So I will comment this tran, and we will enable this DC simulation. So now we run again. Okay. So this is 821 millivolt. So let's plot this